Hello, everybody. My name is Parissa. I'm the Senior Portfolio Manager covering Brimstone product lines with Galvanic. Today, I want to talk specifically on Galvanic Brimstone Sulfur Recovery Unit or SRU analyzers. Brimstone is the third H2S platform of Galvanic with more than 40 years of field-proven history and sulfur recovery units. And it's based on the ultraviolet region of electromagnetic spectrum. There are three main applications when it comes to the sulfur recovery unit plans that we want to focus on today. One of them is the acid feed gas, which refers to the air control at the front end of the SRU plant before feed gas goes to the reaction furnace. Next one is the peat gas application, which is basically to control the H2S and SO2 in the headspace above the sulfur peat. And that's mainly for the safety purposes. That's why people are interested in measuring those. And the most important application in the SRU plants is the tail gas application. That refers basically to analyzing the tail gas at the end of the sulfur recovery unit, that is after the last condenser. And the whole idea is to analyze the H2S and SO2 and find the air demand and see whether they need to add any air or they have to get rid of some air, or where are they at in terms of the air that is going through the reaction furnace. This unit is a close couple unit. There is no need to any sample line. No need to worry about any plugging issues that usually is part of using a sample line if the heat integrity is not addressed properly. The condensation can happen in the process line, so it happens basically at the process line in the Brimstone unit. There is no way that the sulfur is making it to the analyzer and actually sees our system. So we also look at the full spectrum in this unit. So that means that we can measure more than only H2S and SO2, which is very important, for example, for those that are interested in measuring COS and CS2, in addition to H2S and SO2. That will have a lot of advantage, for example, the catalyst protection in the SRU. That's why people want to measure COS and CS2 in this unit. The unit that we are using only uses the low pressure steam. On the right side is a generic diagram that shows the whole process in the sulfur recovery unit. So what happens is at the beginning, the feed gas or the acid gas enters at the front end of the process in the reaction furnace, and the air gets added to it. So the model that we are using for this measurement here, for the acid gas measurement, is the 962 AGX analyzer. Just looks at how much H2S exists in the acid gas before going to the reaction furnace. At the end of the SRU plant, we have two other applications. One of them is just a typical tail gas air demand application. So that's the number 2 here. So that measures H2S and SO2, as well as we have the option to measure COS and CS2. Another application is the double air demand, or the DAD. There is another analyzer right here at number 3, parallel to the number 2. And we basically have an analyzer running after the last condenser as well as after the first condenser. And the idea is to make sure that we can actually capture any issue, any air demand control is required much, much earlier than the whole process going through until we get to the number 2. That's the advantage of using a DAD. Another application is the peat gas, as I introduced earlier, that measures at number 4, the H2S and SO2. At the vapor headspace, and the analyzer model we are using for it is 202SPX. The sample system that we are using in the Brimstone family, what it does for the main part is removing the sulfur and making sure that no sulfur makes it to the analyzer, and it's all taken care of in the process line. So therefore, chances of plugging as well as any crosstalk that can be seen due to the presence of the sulfur and the analysis side is very, very, very low, because all of that sulfur is supposed to be get rid of just during the extraction phase. The sample system in the closed couple model is shorter because we're not using any sample line to extract anything. The advantage is that we will expect a much faster response time in analysis, as well as we'll still minimize risk of the plugging in general because there is no sample line to worry about the heat integrity. Close couple designs, because there is no sample line here, so the chance of having any cold spot is minimized as well. The plugging issues are minimized. That all together results in not having to worry about analyzer going offline because now there is a plugging somewhere and we can get a good sample to our analyzer. So that's why the close coupled solution that we are offering has that advantage compared to the extractive models. The analyzer itself also includes a temperature control oven, which basically maintains the temperature of the sample system portion at around 150 degrees C. This temperature is well above the sulfur dew point temperature. Again, the whole idea is to avoid any plugging, any condensation. The oven is fully electric version, so no expensive, high demand maintenance steam is required. So that's another advantage compared to the designs that just use a high pressure steam as a source of the heat in this case. We have the same approach in using the electric oven to make sure we don't need high pressure steam to keeping that temperature high in the oven. For the measurement, the incoming sample gas basically comes through, it gets filtered in the analyzer. It's drawn through the sample, through the measurement cell by an aspirator. The measurement cell exposes a known length of the sample basically to the UV radiation for the analysis. The aspirator is integral to the measurement cell and it uses instrument air or other inert gases as a ducting media. A broadband UV source lamp is used in the system. The light basically passes through the sample. Some of that gets absorbed by H2S and SO2, or if you're measuring CO2 and CS2, the same thing. And we use a CCD detector that can detect the light. Based on the Beer-Lambert law, the concentration of sample at then can be calculated based on how much light was absorbed. That's how simple and straightforward the measurement happens. The analyzer uses a spectrometer with diffraction grading that is optimized in the spectral region, where the species of interest can basically absorb between about 200 to 400 nanometers. That's coupled to 2048 element detector that basically gives the ability to maximize the sensitivity and the resolution. We are basically scanning through 530 detection points here. This approach definitely provides a more precise multi-species analysis compared to the conventional photometer ways that basically just use a narrow band optical filter. So you see here we have control to the full spectrum that can be really beneficial when we want to look at more species and better accuracy compared to only a few wavelengths to play with. This graph on the right side shows the SRU efficiency loss versus the air demand signal. In an ideal case, the air demand is, as you see in the center, is basically zero. That means everything is perfect, so there is no worries about adjusting the air. On the right side, however, the air demand is on the positive side. So that means too much air is added. So we have to adjust it. We don't need this much. On the left side, the air demand is negative. That means that more air is required for a better efficiency of the system and a better reaction in the SRU in general. And that's why having the TLS analyzer, we can get an idea, or operator can get an idea about how much air is going through, how much is required. Should they cut the air? Should they add more air? Where are they at in this plant? There are several methods that are available in the market to analyze the feed gas composition. As an example, some of them, for example, GC can provide a detailed analysis of the species. However, it takes a few minutes for that analysis to happen, and that exceeds the time requirement to detect and respond quickly during any upset process. Other measurements such as UV, IR, TDL, many more can exist as well. The bottom line is that they're either limited in terms of the potential interferences that they can take care of, or they are matrix dependent, or they might require complex installations or might have sensitive optical designs for the feed gas stream applications. So far, there is no complete solution in the market that can really address all of these measurements without any issue or limitation and with a high degree of accuracy. So that's important. Now, for the tail gas side, the main limitation basically is the process lag time until the sample gets to the analyzer and can be analyzed. So that waiting time is the limitation for that application in the SRU. If there is any hydrocarbon breakthrough, for example, or if there is any sudden feed gas upset, then it takes time to be analyzed, and the time often exceeds what is required for the analyzer to react in a timely manner to avoid going through an upset. So these are the high-level differences or the limitations between the two upstream and downstream measurements in the SRU. Now, between the different methodologies for controlling the whole air demand, one solution is to measure the air demand right after the complicated reaction furnace chemistry to make sure that none of the analysis limitations and concerns that we mentioned for the feed gas section exists. So double air demand, or the DAD, is a patent application. That's the new control strategy by Galvanic Brimstone, and that enables the entire SRU air control in only one package by a combination of stream valve control using the input of the tail gas analyzer after the last condenser, and the main valve control using the input of a similar analyzer after the first. If you look at this diagram here, we will have in this DAD control strategy, we will have an analyzer sitting here as a typical tail gas at number 2 after the last condenser, and we will have one after the first condenser. They will run parallel, and then we will provide all the package together as well as the control system to help communicating with the plants. So the main advantage of it again is the faster detection time to minimize the SO2 emissions at the end of the day, as well as total solution. It's a total solution package for the SRU. So basically you can control the air all the way through from one end to the other end. DAD has a unique and robust sample system. Again, all is close coupled. No specific requirement and adjustment from the plant side is required. To have a quick comparison between the two sample points, basically despite higher amount of the sulfur vapor and the temperature, water vapor is less when we talk about right here after the first condenser. And basically the less water content reduces the required cooling capacity from the sample probe. So in fact, the average cooling capacity here is almost equal for both sample points for the number 1 and 2 I was showing earlier. And it's good that we have actually another analyzer. If one of them goes offline, there is another one that is still reading and controlling the air demand, which is an advantage to offer. The tail gas and the peat gas, as you see on the right side, are very similar in terms of the design and the measurements and ranges for the most part. And as to the gas, as I mentioned earlier, the one on the left side measures H2S in the percent level. Units are electric oven designed, and there is no need to high pressure steam anymore. The unit is certified for a variety of hazardous area classifications as listed here. What I like about this analyzers is that the TLS analyzer for Brimstone actually comes in a couple different configurations and we call them flavors. So if the single unit does not fit on the process pipe, the split version can be offered as well. So the oven cabinet in this system is installed on the process pipe, and the electric cabinet is easily installed farther where there's more space available. That's a good fit for those who don't have enough space on the process side and on the process pipe. So we can offer it as a split version. This is extremely beneficial when the space is limited again. It is also a good replacement opportunity for some of the extractive modules. We have clients coming to us and talking about wanting to get rid of the extractive systems because of the issues with the sample line or heat integrity and all that. So this could be a very good fit for those kind of applications or replacement opportunities. Electronics cabinet. It's all isolated from the oven cabinet. It is purged and it's cooled, and it offers a range of communications that are listed here. So it's capable of communicating different ways. The analyzer itself can also support the remote access, which is another feature and advantage to have. That's through the web-based graphical user interface, or GUI, that allows the user to view the analyzer results or configure the analyzer configuration, carry out manual analysis if they're required to do that. It's accessible through any internet browser. So it can also work simply by connecting the analyzer and just typing in the IP address of the analyzer, and then you'll have access to all the information. So the GUI can operate on a local area network, or just simply through the direct connection of the analyzer and the PC. The analyzer is suitable for -20 degrees C to +60 degrees C. We just recommend keeping the analyzer in a 3-sided shelter just to avoid the exposure to the direct sun or the beam for further protection. But in terms of the functionality and the measurement, the unit is well designed for a wide range of environmental conditions and the temperatures in general. This one here is the quick guide for the scheduled maintenance. So we recommend changing the anti-solarant solution on a quarterly basis. Also the cell O-rings and the windows and source lamp, we recommend changing them annually. We have a strong service support team for the on-site support, including the startups, commissionings, as well as the trainings and the routine maintenance. We also have an experienced team at the factory location that support all the FATs or any remote troubleshooting and other in-house services and support. The main features is a sample inline processing that we mentioned earlier, and basically getting rid of all that sulfur. So when we talk about the sulfur recovery, again, sulfur, heat integrity. That's the whole idea about running a successful analyzer, making sure that these two are addressed. So making sure that we have a system that can get rid of that sulfur in line and process that, that's a huge advantage. It results in having a much less clogging or condensation issues. Another thing is the ability, as we start to install a unit after the first condenser for the DAD systems or the double air demand, parallel to the last condenser, so that provides the opportunity to fully control the air demand for the entire SRU plant. This also helps greatly with reacting in a real-time manner during the upset conditions if they happen, if there is any sudden change in the process feed gas, for example. Brimstone analyzers do not require any high-pressure steam. Again, as we mentioned, is very valuable and it's a great feature to have. So lower costs and troubles, for the operators at the plant. Ammonia excursion or problem happens. The system has the ability to do the steam purging to clean the whole system and just go back quickly to normal and to operation just immediately. The 943 version, it has upgraded several main features, including adding more measurements such as CS2 in addition to other existing ones. The oven is electric oven, as I mentioned, so that's another upgrade feature. The electronics have all been updated as well. Galvanic can support these applications with a high measurement certainty due to the 40 years of the field-proven experience in all this SRU application. Galvanic analyzers offer a rapid return on investment to optimize the air demand control, increase SRU online time, minimize emissions, as well as, most importantly, provide a high level of operators in plant safety, which is very important. At the end of the day, we are working together to have a better presence at the SRE as supported clients for different applications. So please feel free to reach out if you have any specific question, would like to discuss any opportunity or application. I would like to thank you for your attention, and I look forward to working closely with all of you.